Welcome back to I Am One, everybody. Topic 4.1.2, part 2. So, question 412, interpreting the line of best fit. The scatter plot below shows the data collected from 17 different people. It compares the number of years of higher education, years after high school, they received, including trade schools, apprenticeships, and academic colleges. A line of best fit has been drawn for the data right there. So it says part A, interpret the slope. So first focus, again, as always, we want to focus on the line itself. And then after that, we're going to find two exact coordinates, all right, coordinates that the line passes through in order to calculate the slope. And we want to circle those. So again, we want to just focus on the line. So I see one right there. Usually y-intercept is an easy one to pick out. And then if I continue up, I see that the line crosses the grid again here. So I'm going to pick that point again. All right, so let's figure out the slope. So m equals on the y-axis. If you guys notice, we're going by thousands, right? So in this case, 20 would mean 20,000, 40,000, and then right here is up to 50,000. So that means we are going up to 1, 2, 3. So that would be 30 in the thousands over. And then here we're going 4 to the right. So in that one, years of education, we're going up by 1. So be careful right there. Make sure you guys are reading the graph correctly. And if you simplify that, you end up with pretty much just 7.5. All right. So in this case, it says use a number to describe the rate of change, right? The rate of change in the trend of the scatter plot. The slope tells us that there's an average salary increase, right? Because it's going up, an average salary increase of, and in this case, 7.5 or 7,500, right? Because it's in the thousands, 7,500 for every year of education past high school. So the trend line tells us precisely that, right? That 30,000 bucks over 4 years, or pretty much 7.5 or $7,500,000 per year. So this is money per year, right? Because remember, the slope represents a rate of change. So it's something over something. We're comparing two quantities. Now we want to, part B, we want to interpret the y-intercept. It says identify the y-intercept of the line itself. Again, the line itself, not the points that are scattered all over the place. All right, so it says use this number to describe the initial or beginning value of the situation. So again, in this case, it seems to me like it's about 0, comma 20. All right, so that's our B. So 0, comma 20. And again, this would be year 0, right? And then this would be the starting salary or the salary in the thousands, right? So in the thousands. Okay. So now we're going to fill out the rest of it. This is the y-intercept. So the y-intercept tells us that the average starting salary, right? Because remember, the y-intercept is also called our initial value. So we can say that the average starting salary for a person with 0 years of education past high school is 20,000, right? 20K. Right? Why am I saying 0 years? Because again, that's the initial one, right? So pretty much this is what's telling you that people that usually after they start working after they graduate from high school, on average, they make about $20,000 per year. All right. So now let's look at part C. It says use a line of best fit to determine the average salary a person with 7 years of education might be predicted to receive. So first we want to find 7 years on the x-axis and follow it up to, right, the y value, which itself, or the y points on the line, right, up to the line itself, the line. So let's go right there. So we're going to find 7 on the x-axis, which is here. And then we start going up, and then we see that it's about right there. So let's say about 70. Let's say it's 70 right there. Here we go. So we can say that not a point from the scatter plot that corresponds to center, right? So again, we want to focus on the line itself. It says, or use 7 as x in the equation for the line of best fits, right? In this case, we know that the line of best fit, we have a slope, so y equals 7.5 times x, and then our initial value is 20, okay? So a person, it says that would make, that would be 7 years of trade school apprenticeships or anything else after high school times 7 is plus your initial value, which is 20. So that would give us pretty much 7 times 7.5, that's 49, plus 3.5 gives us 52.5, plus 20,000, or 20, sorry. That's a total of 72.5. So according to the line of best fit, a person with 7 years of education past high school might expect to receive an a yearly salary, right? Because we're talking about years, right? A yearly salary of approximately $72,500. So again, the line of best fit will help us predict what a person, in this case, has been that has 7 years of education past high school, might get a starting salary, or I'm sorry, not a starting salary, but a salary of 72,500. All right, question 413. The scatter plot below shows the cell phone battery life of 15 different people recorded at different hours of the day, beginning after 7 a.m. Interpret the slope of the line of best fit. That's the first thing we want to do. So just interpreting the line of best. So again, we want to pick a point. We'll circle the first one right there. And then here, I'll find another point that goes through the grid. And it seems to be about right there. So just remember, focus on the line itself. So we went down. It says the battery life percentage. And then this is hours. So we have a percentage of battery life divided by hours. So here we know that the slope, so let's find it. So m equals, in this case, we said it's the battery life divided by the number of hours it lasts, right? So that's the rate of change. So here it goes down 40%, right? It goes down 40%. This is a percentage, and then this is in, well, this is time, right? So 40% after 5 hours. So pretty much we can say, if we simplify that fraction, we can say that it goes down 8% every hour. All right. And then it says interpret the y-intercept of the line of best fit. So here in this case, the line of best fits is right there. So that would be our starting. So the y-intercept is 0, comma 100. And in this case, we want to say it's the starting charge, right? Starting charge in percent of the cell phone.